Imagine staring up at the night sky on a crisp September evening, the stars twinkling like distant promises. You've heard the whispers online. Another interstellar visitor slicing through our solar system. But what if I told you this one isn't traveling alone? What if, in the blink of an eye, it unleashed a fleet of mysterious escorts, each pulsing with energy that defies everything we know about the cosmos? Welcome to the edge of the unknown, where science meets the stuff of dreams, and maybe nightmares. Today we're diving deep into the enigma of 3I/ATLAS, the third confirmed interstellar comet to grace our neighborhood, and its 9 shadowy companions that appeared out of nowhere. Why does this matter? Because if these aren't just rocks from another star system, but something engineered, it could rewrite our place in the universe. Stick around as we unpack the discovery, the science, the theories, and what it all means for humanity's future in space exploration. If you're a space enthusiast, a curious beginner, or just someone who wonders if we're really alone, hit that like button now and let's launch into this interstellar thriller. For months leading up to that fateful night, astronomers around the globe had their eyes glued to 3I/ATLAS. Discovered by the ATLAS survey in July 2025, this comet, nicknamed 3I for its eerie triple-lobe shape in early images, barreled in from the depths of interstellar space, following in the footsteps of Oumuamua in 2017 and 2I/Borisov in 2019. Like its predecessors, it was a wanderer from beyond our solar system, a frozen relic hurtling at speeds we can barely fathom, over 30 kilometers per second, fast enough to cross from the sun to Pluto in a single Earth year. But unlike those earlier visitors, 3I/ATLAS stood out from the start. Its tail glowed an unnatural emerald green, a hue caused by diatomic carbon in its coma, the hazy envelope of gas and dust surrounding the nucleus. Fun fact, that green isn't just pretty, it's a signature of comets rich in organic compounds, hinting at the building blocks of life frozen in time for billions of years. As it swept closer, passing Mars at a tantalizing 29 million kilometers on October 3rd, probes like NASA's Mars Reconnaissance Orbiter and the European Space Agency's Mars Express turned their gaze, snapping images that revealed a nucleus roughly 1 kilometer wide, larger and more active than expected for an interstellar drifter. Everyone thought they had it figured out. A natural comet, perhaps the oldest we've ever spotted, with an orbit suggesting it formed in the chilly outer reaches of another star system. But then, on September 19th at 2 a.m. UTC, the sky played its wild card. Picture this, an amateur astronomer in the Atacama Desert, Chile. Let's call him Javier, a teacher by day with a passion for the stars, sets up his modest 0.5-meter telescope on a lonely hillside. He's been tracking 3I/ATLAS for weeks, sharing grainy shots on forums like Reddit's r/astronomy. That night, as the comet crests the horizon, his camera captures something anomalous. 9 faint specks of light, orbiting the main body like ghostly satellites. At first, Javier thinks it's lens flare or cosmic ray hits, common glitches in astrophotography. He uploads the stack anyway, just in case. Within hours, the astronomy community erupts. Professional observatories scramble. The James Webb Space Telescope pivots its golden mirrors. Hubble's wide-field camera 3 zooms in. And the European Southern Observatory's Very Large Telescope in Chile confirms it all. There they are, 9 distinct objects, each no bigger than a city block, moving in lockstep with 3I/ATLAS. Not debris, not illusions. Real companions, radiating that same eerie green glow. It's as if the comet wasn't a lone wolf after all, but the flagship of a silent convoy. And just like that, our solar system went from hosting 1 interstellar guest to 10. How do you even wrap your head around that? It's like discovering your quiet neighbor is actually leading a parade you never noticed. As the initial shock waves rippled through observatories from Hawaii to the Canary Islands, the real detective work kicked in. Spectral analysis, breaking down the light from these objects into its rainbow components, painted a picture straight out of science fiction, but grounded in hard data. The companions weren't chunks of the comet's icy nucleus. They carried identical metallic signatures, high concentrations of nickel, cobalt, and rare alloys like iridium and osmium, elements more common in asteroid belts than cometary fluff. Think of it this way. If 3I/ATLAS is a fluffy snowball laced with organics, these nine are like polished steel marbles tucked in its pocket, dense, reflective, and unnaturally uniform. Their thermal profiles? Even wilder. While the main comet's nucleus hummed along with a modest 10 gigawatt output, enough to power a small country, the escorts each blazed at 20 gigawatts, contained in volumes smaller than Manhattan. To put that in perspective, the International Space Station sips just 100 kilowatts. These things are outputting the energy of nuclear plants squeezed into ice cubes. Natural comets don't do that. They sublimate gas under solar heat, not ignite like contained stars. Pause for a second and let that sink in. We're talking power levels that scream not random, but engineered precision. Avi Loeb, the Harvard astrophysicist who first speculated about Oumuamua's artificial origins, called it the smoking gun we've been waiting for. Could these be fragments from a collision? Sure, in theory, but models run on supercomputers at NASA's Jet Propulsion Laboratory show collision debris scatters chaotically, not orbits in perfect synchrony like a well-rehearsed dance troupe. No, these nine moved as one, their paths mirroring 3I/ATLAS down to the decimal. It's the kind of harmony that makes you wonder, who or what programmed this ballet? But here's where the story twists from intriguing to downright spine-tingling. The companions didn't just tag along, they materialized. For weeks prior, every telescope on Earth and in orbit had 3I/ATLAS in its crosshairs. The Parker Solar Probe, dancing through the sun's corona, relayed data. Juno, orbiting Jupiter, cross-checked trajectories. Not a whisper of these escorts. Then bam! September 19th, they blink into existence in under a millisecond. That's 300 times faster than a human blink, quicker than the fastest camera shutter. Loeb's team at the Galileo project crunched the timestamps. No gradual emergence, no dust cloud precursor. It's as if a veil lifted, revealing what was hidden all along, or deployed on command. Imagine a submarine surfacing, not with a slow bubble, but popping up like a cork. Theories flew fast. Were they dormant subsystems activated by the sun's magnetic tug as 3I/ATLAS crossed the heliopause? Or did the main body birth them, like a mothership releasing drones for a planetary flyby? Skeptics clung to natural explanations, a micro-collision with interstellar dust perhaps, but the energy math doesn't add up. Dust impacts fracture, they don't forge reactors, and that green tail. Each companion sported its own, synchronized in wavelength, like echoes in a cosmic canyon. As Michio Kaku put it in a recent interview, this isn't astronomy anymore. It's astrobiology or astrotechnology. From basic orbital mechanics to quantum-level emissions, every layer peeled back revealed more questions. What triggered the reveal? And why now, as 3I/ATLAS hurtles toward its perihelion, the sun's closest kiss, in late October? Shifting gears from the how to the why, let's talk purpose. If these aren't natural flotsam, and the data leans hard that way, what could nine high-powered escorts be for? Start simple. Scouts. In a hypothetical scenario backed by Loeb's models, 3I/ATLAS acts as a carrier, slinging probes ahead to map the inner solar system while the mothership hangs back, safe from solar flares and gravitational tugs. Their beefier power cores, those 20-gigawatt hearts, would let them dive closer to planets, sniffing atmospheres or scanning biosignatures without frying. Earth's a prime target. Our magnetic field, buzzing with radio chatter from billions of minds, would light up like a beacon. Fun analogy, it's like sending drones ahead of a delivery truck to scout the neighborhood. But peel back the optimism and darker possibilities emerge. Theoretical, of course, but rooted in physics. That much energy in such small packages? It's overkill for sightseeing. Weaponized, harvesters stripping volatiles from moons, or enforcers primed to neutralize rivals? Remember, Oumuamua's odd acceleration puzzled us. 3I/ATLAS's escorts amplify that tenfold. Spectral lines hint at exotic propulsion, maybe antimatter traces, or zero-point energy fields. Concepts from peer-reviewed papers in Nature Astronomy that stretch our fusion tech to its limits. No one's claiming aliens yet. That's sensationalism we avoid here. But the intent feels deliberate. Their formation isn't a swarm, it's a phalanx. Rhetorical question time. If you were an advanced civilization scouting a new star, would you send one probe or a backup fleet? Exactly. And as these 9 fan out, subtly altering their spacing for optimal coverage, we're left pondering, are they watching us or preparing? Now zoom out to the human side, because discoveries like this don't stay in ivory towers. They crash into boardrooms and briefings. As images flooded social media, Javier's backyard shot going viral with millions of views, official responses trickled in like molasses. NASA acknowledged anomalous features in a terse press release, promising more data from Webb's infrared gaze. ESA echoed with ongoing observations, while China's National Space Administration stayed mum, though satellite reallocations suggest they're all in. Behind the curtain, leaks from sources like the debrief paint a frantic picture. Pentagon war rooms buzzing with planetary defense scenarios, ESA dusting off Don Quixote, asteroid deflector blueprints, and SpaceX quietly tweaking Starship payloads for rapid intercepts. Why the hush? Transparency could spark panic. Imagine headlines screaming, "Alien fleet incoming," but silence breeds its own fears. Why withhold raw spectra that could debunk the hype? It's a delicate dance. Reassure the public while prepping contingencies. Historical parallel. When Oumuamua zipped by, Loeb's probe idea got laughed off. Now, with 3I/ATLAS, governments are listening. Private players like Blue Origin are looped in, hinting at a unified front. Yet for everyday folks, it's amateurs like Javier driving the narrative, turning backyards into observatories. That's the beauty of space exploration. It's democratized. Your phone's astrophotography app could spot the next big thing. But amid the excitement, a sobering note. If these escorts pack nation-level power, our defenses, kinetic impactors, nukes on rockets, are Stone Age by comparison. Time to invest in that multi-planetary future Elon keeps talking about. Layer on the weirdness, and the plot thickens with ripples no one saw coming. Days after the reveal, ground-based sensors lit up like a Christmas tree. Magnetometers in Antarctica and Hawaii picked up 43-second pulses, syncing with the convoy's orbit. Faint but rhythmic, like a stellar heartbeat. Seismographs in the Andes logged microtremors with no earthquake tie-in. Even wildlife acted off script. Pacific whale pods veered 200 kilometers off course. European bird migrations looped erratically. Coincidence? In isolation, maybe. Together. It's as if the solar system's wiring got a subtle tweak. Then the kicker. Radio telescopes in Arecibo's shadow caught a burst from one escort. Not toward Earth, but the moon. Pinpoint accurate, slamming into a mascon. Those mysterious mass concentrations under the lunar crust that mess with Apollo orbits. The signal? Structured code, modulated in ways that scream information, not noise. What if the moon's not just cheese rind rock, but a dormant relay etched with tech eons old? Theoretical, sure, backed by lunar anomaly studies in science, but it flips the script. Are these escorts pinging an ancient network, awakening something we've walked on without knowing? It's the kind of hypothetical that keeps SETI researchers up at night, scanning for replies. And just when you think it can't get more synchronized, enter C/2025R2. Nicknamed Swan for its sweeping, luminous tail 5 times the full moon's width. This behemoth, 100 times brighter than 3I/ATLAS, barrels in from the opposite vector, perihelion timed to overlap in mid-October, a mere 50 million kilometers apart. Random chance? Odds are astronomical, literally 1 in a trillion for two interstellar giants to thread the same solar needle. To optimists, Swan's a counterbalance, a natural shepherd herding the convoy away. Pessimists see convergence. Refuel at the sun's pump, swap data mid-flight, or worse, rendezvous for reasons we can't guess. Historians add fuel, citing ancient logs, a 200 BCE Chinese green dragon comet, Babylonian splitting stars, a 1000 CE European emerald banner, cycles every 2,200 years. If true, this isn't first contact, it's a sequel. Humanity's survived before, etching warnings in stone. But now, with telescopes piercing the veil, survival means understanding. As Swan looms, the blackout nears, solar glare hiding the dance. Will we miss the climax? Woo! That's the whirlwind of 3I/ATLAS and its 9 escorts. From a lone green-tailed comet to a potential interstellar armada, challenging physics, stirring governments, and echoing through history. Key takeaways? First, interstellar objects aren't rare anomalies. They're windows to other worlds, carrying chemistry that could see life or tech that mimics it. Second, anomalies like sudden appearances and power spikes push us to rethink natural, blending astronomy with astrobiology in ways that demand better tools, like Loeb's proposed UN-led interstellar interceptors. Third, this underscores space exploration's urgency. Mars missions, Artemis lunar returns, Starship's Mars hops, they're not luxuries, they're insurance. Thought provokers to chew on. If these are probes, who sent them? And what's the message? Are we the anomaly in their logs, or just background noise? Does Swan's arrival herald harmony or heighten the stakes? Drop your theories in the comments. Let's build a community of cosmic detectives. If this sparked your wonder, smash that subscribe for more deep dives into black holes explained, Mars colonization updates, and the latest from NASA and ESA. Like if you're team probes, comment your wildest scenario, and check out my video on Oumuamua's secrets next. Link in the description. Until the stars align again, keep looking up. The universe is whispering. Are you listening?